Let's go through a few parameters of a wave. What is a wave? It is an oscillation followed by a transfer of energy travel through a medium. The wavelength of a wave is referring to the distance it travels in one cycle. The symbol is lambda, and the unit is meter. You may measure it from one peak to the next peak. The peak can be the positive peak or the negative peak. In this example, the wavelength is 2 meters. The next parameter is frequency. Frequency is the number of cycle the wave travel in 1 second, and the unit is hertz. The frequency is equal to velocity divided by the wavelength. For a sound wave, the velocity is 343.21 meter per second in air and 1484 meter per second in the water. For a radio wave, the velocity is 3 multiplied by 10 to a power of 8. In this example, we assume it as a sound wave travel in air. Therefore, the frequency is equal to 172.6 Hz. A sound wave or radio wave is usually made up of multiple waves. Therefore, the bandwidth required for the system is equal to the difference between the highest frequency and the lowest frequency. In this example, the highest frequency is 10 kHz, and the lowest frequency is 2 kHz. Therefore, the bandwidth is equal to 8 kHz. Now, we come to the sine wave values. The amplitude of a sine wave refers to the signal's peak value, and the symbol is Vp. The peak-to-peak value is referring to the difference between the positive peak and the negative peak. The RMS value is the root mean square of the signal. It is equal to 0.707 multiplied by phi, or Vp, divided by square root of 2. In this example, the amplitude, V peak, is equal to 25 volt. The V peak to peak is equal to 50 volt. The VRMS is equal to 0.707 multiplied by V peak, and the answer is 17.68 volt. A stroke of a tuning fork may generate a single tone, and a striking with a hammer will generate a complex sound wave. To analyze a complex sound wave or radio wave, we have to plot the signal in frequency domain. In this example, we have a sine wave of 2 kHz. To plot the sine wave in frequency domain, the frequency is the x-axis. We draw a vertical line at some point of the x-axis and label it as 2 kHz. The height of the line is the amplitude of the sine wave. In the second example, the system adds two sine waves of 2 kHz and 10 kHz together. To plot the resulting signal in frequency domain, we draw two vertical lines on the x-axis, the lower frequency on the left and the higher frequency on the right. Likewise, the height of the lines is the amplitude of the signals.